Hello and welcome to my channel. In this video we will solve problem 3 and problem 4 of exercise 12.1 in 12th class maths. Okay, so the third problem is what? Maximize z equal to 5x plus 3y subject to 3x plus 5y less than or equal to 15, 5x plus 2y less than or equal to 10, x greater than or equal to 0, y greater than or equal to 0. So we have to find the maximum of this function here subject to the given constraints, that is the conditions. Okay, so let us solve this problem. Solution. So let us write what is given to us. So given a maximum z equal to 5x plus 3y subject to 3x plus 5y less than or equal to 15, and then 5x plus 2y less than or equal to 10, then x greater than or equal to 0, y greater than or equal to 0. Okay, so now what we will do, we will take the first line here. So line 1, let us call that line. So line 1 is nothing but 3x plus 5y equal to 15. Okay, so the inequality is converted into equality here. Now let us make the table for this line. So this is x and y will be what? So if we take 3x on this side, so 15 minus 3x divided by 5. Okay, now if we take x equal to 0, we will get 15 by 5, which is 3. Then if we take x equal to 5, we will get 15 minus 15 divided by 5, so that is 0 by 5, that is 0. Then if we take x equal to 10, so x equal to minus 5 if we take, so we will get 15 plus 15 divided by 5, so 30 by 5, right, which is 6. So this is what we will get. Okay, so this is the table for the first line. So now let us go to the line 2. So line 2 is this 5x plus 2y less than or equal to 10 will be 5x plus 2y equal to 10. So 5x plus 2y equal to 10, right? So we will take x and y will be what? 10 minus 5x divided by 2. Okay, so if we take x equal to 0 here, we will get 10 by 2, which is 5. Then if we take x equal to 2, we will get 10 minus 10 divided by 2, that is 0. If we take x equal to 4, so 10 minus 20 divided by 2, that is minus 10 by 2, which is minus 5, right? So okay, we will take 4 here. So x minus 20 divided by 2, yeah, that is the same. So minus 10 by 2, which is minus 5. If we take 4, we will get minus 5. Okay, so this is the table for the line 2. Then line 3, if we take, it is corresponding to this inequality, x greater than or equal to 0, so that will be x equal to 0, which is nothing but the y axis, right? Then line 4 will be y equal to 0, so that is nothing but the x axis, right? Now let us plot the lines. So suppose this is the y axis and this is the x axis, right? So y axis, this is the x axis, then this is the origin. Now we will write the numbers here. So 1 2, that is the scale, 1 2 3 4 5, 6, 7, 8, 9, 10, right? So that is the first for x-axis. Here you will get -1, -2, -3, -4, -5. Okay, then here it is 1, 2, 3, 4, 5, 6, and here it is -1, -2, -3, -4, -5. Okay, so if we look at the first line, it is this. So first point is 0, 3, that is here. Okay, 0, 3, then 5, 0, 5, 0, that is this. Then -5, 6, -5 and 6 here. Okay, so if you plot the line that is joining these 3 points, okay, this line we get. Let us name the line. It is 3x plus 5y equal to 15. 3x plus 5y equal to 15. Okay, and now let us go to the line 2. So the points are 0, 5, 0, 5, then 2, 0, and 4, -5. Okay, 4, -5 here. So let us join these 3 points, and now let us name this line here. So it is 5x plus 2y equal to 10. 5x plus 2y equal to 10. Okay, now these lines will be what? X equal to 0 is the y-axis, so that is this line here, and y equal to 0 is the x-axis, that is this x-axis. Okay, now what we have to do is find the solution region for each inequality. So that is, we have to put 0, 0. So put 0, 0 in the first inequality, that is this 3x plus 5y less than or equal to 15 in 3x plus 5y less than or equal to 15. Okay, so therefore what we get is 3 times 0, because x is 0, and 5 times again 0, because y is also 0, less than or equal to 15, and so this will be 0 less than or equal to 15, which is true, right? So therefore the inequality is satisfied. The inequality is satisfied. So the solution region is the half plane. Solution region is the half plane where the point 0, 0 lies. Okay, that is the point which you have substituted. Okay, so the solution region for the first line here is this, on the side where 0, 0 lies, right? So on this side of the line, right? Now let us find the solution region of the second line. So put 0, 0 in the second line, second inequality. 5x plus 2y less than or equal to 10. 5x plus 2y less than or equal to 10. Therefore, what we get is 5 times 0 plus 2 times 0 less than or equal to 10. Okay, that is nothing but 0 less than or equal to 10, which is true. So therefore, the inequality is satisfied. Therefore, the inequality is satisfied. So the solution is the half plane solution region. Solution region is the half plane where 0, 0 lies, right? Where 0, 0 lies. So the solution region for this line is here. Okay, here. And now let us go to the third line. So x equal to 0, so x greater than or equal to 0, so that means on the right hand side of the y axis, right? This we have seen. Okay, and y greater than or equal to 0 means above the x axis. So here right, and now if we look at the intersection of all these regions, we get this region here. Okay, this region we get. So let us name this point. So this is O, this is A, this is B, this is C, right? Now so let us find the point B first. So to find point B, okay, that is this point here. So we have to take the intersection of both the lines, that is 3x plus 5y equal to 15, 5x plus 2y equal to 10. 3x plus 5y equal to 15, and what is the second line? 5x plus 2y equal to 10. Okay, so what we will do is multiply 2 for this and 5 for this. What we will get is 6x plus 10y equal to 30. 5 times 5 is 25x plus 5 times 2 is 10y equal to 5 times 10 is 15. So minus minus minus, okay, this gets cancelled, and then minus 25 plus 6 is minus 19x equal to 30 minus 50 is minus 20. So that means x is nothing but 20 by 19. Okay, now let us substitute x in the second equation. Substituting to find y, right? Substituting x equal to 20 by 19 in this 5x plus 2y equal to 10. So what we will get is 5 times 20 by 19 plus 2y equal to 10, right? So that means this implies 100 by 19 plus 2y equal to 10. So 2y is equal to 10 minus 100 by 19. So that means 2y is equal to 190 minus 100 divided by 19. Okay, so that means 2y is equal to 90 by 19. So what we get is 2 1s are 2, 2 45s are 90. So y is nothing but 45 by 19. Okay, so therefore the point B will be what? X is 20 by 19. X coordinate is 20 by 19, y coordinate is 45 by 19. Okay, so now we are ready to find the maximum of the function. Okay, so so for that, at first point we have to find the z at origin 0, 0. What will be z? Z function is 5x plus 3y. So 5 times 0 plus 3 times 0, that is equal to 0. Then at a, so that is 2, 0. So z will be 5 times 2 plus 3 times 0, that is 10, right? Then at b, b we have found out 20 by 19, comma 45 by 19. Okay, so z is nothing but 5 times 20 by 19 plus 3 times 45 by 19. Okay, so z is nothing but 100 by 19 plus 45 times 3. If we do 3 5s are 15, 3 4s are 12, 12 plus 1 is 3, so 135 by 19. Okay, so this implies z is 235 by 19. Okay, and at c, which is this 0, 3, what is z? Z is 5 times 0 plus 3 times 3, so that means z is 9. Okay, so maximum it looks like it is this. Let us check, because this is in fraction. Let us convert it into decimal number. So 19 to 35, 19 ones are 19, right? 23 minus 19 is 4, and then 5, so 19 into 2 if we do, so that is 9 to the 18 plus 1, 38, right? So 12, so 38. Okay, so this is 7, this is smaller than 7 is smaller than 19, so 0 we take point, so it is 12 point something, and which is greater than all these z values, right? So therefore the maximum z is equal to 235 by 19 at b, which is 20 by 19, comma 45 by 19. Okay, so this is the solution of the first problem in the video, that is the third problem. Now fourth, the problem is minimize z equal to 3x plus 5y such that x plus 3y is greater than or equal to 3, x plus y is greater than or equal to 2, x comma y is greater than or equal to 0. Okay, we have to minimize the given function subject to these constraints. Let us solve this problem. Solution. So given we will write first. So minimum z is equal to 3x plus 5y subject to x plus 3y greater than or equal to 3, x plus y greater than or equal to 2, x comma y greater than or equal to 0. Okay, so now first of all we have to consider the first line, line 1. So that is corresponding to the first inequality. So x plus 3y equal to 3, right? So this is x, and then y will be what? 3 minus x divided by 3. Okay, so if we take x equal to 0, we will get 1, and if we take x equal to 3, we will get 0, right? And if we take x equal to 6, we will get minus 1. Okay, so this is the table for the first line. Okay, then line 2 let us take. So that is corresponding to this inequality, x plus y equal to 2, right? So x is this, y is 2 minus x. So when x is equal to 0, y is 2. When x is equal to 2, y is 0. And when x is equal to 4, y is minus 2. Okay, so this is the table for the line 2. And line 3 is just for the third inequality. So that is x greater than or equal to 0. That means it is x equal to 0, which is nothing but the y axis, right? And line 4 is y equal to 0, that is nothing but the x axis. Now let us plot the lines. This is the y axis, this is the x axis. Okay, so this is the x axis, then this is the y axis. Now we will take the scale here. So that is 1, 2, 3, 4, 5, 6, 7, 8. Okay, here minus 1, minus 2, minus 3, minus 4. Okay, here it is 1, 2, 3, 4, 5, 6. All right, and then here it is minus 1, minus 2, minus 3, minus 4. Now let us plot the lines. So first point of first line is 0, 1. So here, okay, this is 0, 1. Then we have 3, 0. Okay, 3, 0, and then 6, minus 1. So 6, minus 1 is here. So if we join these 3 points, we get this line. Okay, and the name of the line is x plus 3y equal to 3. Right, now let us plot the second line. So 0, 2 is the first point, then 2, 0 is the next point, and 4, minus 2 is the third point. 4, minus 2. So if we join these points, we get this line, and the name of the line is x plus y equal to 2. So now let us find the solution region of each inequality. So for that we have to put 0, 0 in this inequality. First inequality, x plus 3y greater than or equal to 3. Okay, so that is 0 plus 3 times 0 greater than or equal to 3. So that means 0 is greater than or equal to 3. Okay, and so this is false, right? So therefore the solution region is the half plane where the 0, 0 lies. It doesn't lie because the inequality is not satisfied. Okay, does not lie. So because inequality is not satisfied, the solution region is the half plane where 0, 0 does not lie. So that means this, right, this region. And if we put 0, 0 in the second line, so put 0, 0 in this x plus y greater than or equal to 2. Okay, so that is 0 plus 0 greater than or equal to 2. So that means 0 is greater than or equal to 2 is false, right? So therefore solution region is the half plane where 0, 0 does not lie. Okay, so if we mark the solution region, it is this. Here the 0, 0 doesn't lie, right? Okay, now if you look at the and these inequalities, x greater than or equal to 0 means on the right hand side of y axis, so we will mark it here. And y greater than or equal to 0 means the region above the x axis, that is this. Okay, and if you look at now the intersection of all these regions, it is this. Right, so that means this we will name it as A, and B this point, and this is C, right? So now what we have to do is first of all observe the feasible region. So this feasible region is unbounded, you can see, right? So the feasible region here, the feasible region A, B, C, okay, is unbounded. No need to write this. Feasible region is unbounded. Okay, now there is a different method to solve this type of problems. When we get feasible region is unbounded, what we have to do is the following. First of all, you have to find the uh, objective function at the corner points. Okay, so let us find the objective function at the corner point. So first of all, at a, so what is a? A is 3, 0. The objective function z is 3x plus 5y. So that means you will get 3 times 0 plus 5 times 0, right? So that is 0. Then b point we have to find, right? So for that we have to solve the linear equation in two variable to find x and y. X plus 3y equal to 3, x plus y equal to 2. X plus 3y equal to 3, x plus y equal to 2. So we will take minus here. This gets cancelled. 3y minus y is 2y equal to 3 minus 2 is 1. Okay, so this implies y is equal to half. So this is the y point. Okay, now y equal to half we will substitute in the second inequality. So that means x plus second equality, sorry, x plus half equal to 2. So that means x is equal to 2 minus half. So that is nothing but x is equal to 3 by 2. So therefore the point b will be 3 by 2 comma 1 by 2. Okay, so now we can find the objective function at b. B is 3 by 2 comma half. So z is equal to 3 into 3 by 2 plus 5 into half. So this implies z is equal to 9 by 2 plus 5 by 2. So that is z is equal to 14 by 2. So that means z is equal to 7, right? Now at point C, that is this 0, 0, 2, right? Yeah. Point C is 0, 2, correct. So there z is equal to 3 into 0 plus 5 into 2, so which is nothing but 10. Okay, here we had to substitute 3. There is a mistake here. 3 into 3, so we will get 9 here. Okay, so now what is the minimum of the objective function at b? It is what is the minimum of the objective function from this? It is 7, right? So now what we have to do is this, we have to take the objective functions LHS, that is 3x plus 5y. Okay, so we have to take this objective function LHS, that is 3x plus 5y. Okay, and since we have to find the minimum, what we have to take is less than. Okay, since it is minimum, we have to take less than, and we have to take the minimum value of objective function, that is 7. Okay, now what we have to do is plot this line corresponding to this inequality and plot it on the graph, and if there is the intersection point between the feasible region and the solution region of the inequality, new inequality, then we conclude that there is no minimum for the function. Okay, and if there is no common point between the two regions, we take the minimum as the minimum of the objective function at the corner points wherever we have got. Okay, that is b. Okay, so now let us take the line corresponding to this inequality. So 3x plus 5y equal to 7, right? So x and then y is equal to 7 minus 3x divided by 5. Okay, So if we take x equal to minus 1, right? So we get 7 plus 3 by 2, that is 10 plus 5, which is 2. And then if we take minus okay, we can take 0, 1, 4, 3, 9, 4, 12. Yeah, if we take 4, so what do we get? 7 minus 12, right? 7 minus 12, which is minus 5, so minus 1. Okay, these 2 points we got. So let us plot the line. Yeah, so if you plot the line, so first point is minus 1 comma 2, minus 1 comma 2 here, right? And the second point is what? 4 comma minus 1, 4 comma minus 1 comma 2 is not here. Minus 1 comma 2 is here, and then 4 comma minus 1, right? 4 comma minus 1, 4 comma minus 1 is here. We will take this line, right? So you can see, if we look at the solution region now, so put 0 comma 0 in this 3x plus 5y equal to less than 7, right? So 3 times 0 plus 5 times 0 less than or equal to 7. So 0 less than or equal to 7 is true. So therefore the inequality is satisfied. Okay, therefore the solution region is the half plane where 0 comma 0 lies. Okay, so the feasible region for the line is this here. And so you can see that there is no common point between the unbounded region and this solution region of the new inequality. Okay, so therefore we conclude that the minimum is 7. Okay, now since there is no common point between the feasible region of the problem and this region 3x plus 5y less than 7, therefore the minimum z is nothing but 7 at which point? It is b, 3 by 2 comma half. Okay, so this is the solution. So that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.